3.7 about higher derivatives is really nothing at all. The whole section is not that, there's almost nothing in it. So higher derivatives. It's simply that it's okay to take the derivative of a derivative. So the notation is like this. If you have one prime on it, it means it's the first derivative, and if you put two primes on it, that means you're taking the derivative of the derivative, right? And so you could have as many primes on it as you like, and that would be the if there were k of these guys, then this would be the k derivative of your function, right? There are other notations for it. People sometimes use a number inside parentheses, right? So if I wrote f5, that would mean the fifth derivative, right? With the Leibniz notation, people write like this. They write a k, the k on the top and bottom. It's sort of like I think it'd probably be more logical to write like this, right? To write some sort of power, but instead people write it like this. That's just a notation. Again, this means the fifth derivative, the kth derivative. This also means the kth derivative if you use the big D notation. Okay. So there's nothing. That's almost all that's in this section. So for example, some of the problems go like this. If k of x, you have some function k of x, and that is sine of x cubed minus 3x. Okay. Then what's the take the second? Actually, the problem is to take the third derivative of this one. Let's not do that much busy work. Let's take 1 minute and find the second derivative. Right. So take the derivative and then take the derivative of the derivative. This section is like my bane because I cannot pronounce the word derivative. I always have trouble saying it. Now I have to say it multiple times. Okay, turn to somebody next to you and say what you got.
It's just powerful. Yeah, so x is 0. Then this must be the first time. Yeah. And then
Okay. It sounds like some people have even forgotten how to do derivatives in the meantime, so maybe this was a good section to start off with. So let's do it. Right? What's the first derivative? What do you use for this sort of thing?
chain.
The chain rule, right? you have a composition of functions, right? This is the outside function, this is the inside function. You take the derivative of the outside function, which is cosine. You evaluate it at the inside function, and then what do? You multiply by the derivative of the inside guy, so it's 3x squared minus 3, right? So that's your first derivative, right? And then your second derivative, what will be involved there? Product rule, right? You have two functions, this function times that function, and so you'll take the first guy times the derivative of the second guy, first guy times the derivative of the second guy, right?
I'm sorry, can you explain again with that x, why you brought down the x cubed minus 3x?
X cubed minus 3.
Why you brought it down?
Are you talking about going from here to here?
Yes.
Okay, so this is the product rule, right? Remember that if you're differentiating the composition, if you're taking the derivative of the composition, what you're going to get is the outside guy's derivative evaluated at f of x times f prime x. So here, your g is the sine function, right? G of x is sine, and your f is x cubed minus 3x, right? So when you take the derivative of this composition, right? This is g of f. When you take the derivative of the composition, you're going to take the derivative of g. Well, what's the derivative of g? That's the cosine, right? That's the cosine, and you're going to evaluate the cosine at f of x, right? So you take cosine. You're going to evaluate the cosine at f of x.
Okay, I see what you're saying.
You evaluate the cosine at f of x, and then you multiply by f prime x. Well, f prime is 3x squared minus 3 e to the power of. Oops.
Okay.
Okay. Okay. And then to do the second derivative, we're going to use the product rule. So you take the first guy, the derivative of the second guy, 6x minus 0, right? And then plus the derivative of the first guy. Well, what's that? Somebody want to tell me?
Negative sine x.
Negative sine.
Yes.
Times minus 3
C minus 3x.
times 3x squared minus 3.
Times 3x squared minus 3. So that's the derivative of the first guy, and then times the second guy. Okay. So I hope that's what you got, right? This is the first guy, this is the derivative of the second guy, this is the derivative of the first guy, right? This is the derivative of the first guy, and then this is the second guy. The first guy times the derivative of the second guy plus the derivative of the first guy times the second guy. Okay. Everyone all right with that? Anyone? Okay. Okay. Well, why don't we do another just to remind everybody how to do these sorts of things. What's the second derivative of this one? Okay. Again, take 1 minute and try to do it. Okay, turn to somebody nearby again and compare answers.
So wait, is that the derivative?
Yeah. No, the derivative is
So the bottom. Minus 2.
Okay, I would like to say how to do it. Okay, go ahead, Claire.
So I use the quotient rule to find the first derivative.
Okay, so at the bottom times the derivative of the top minus the top times the derivative of the bottom, which is 1, over the bottom square.
And then I distribute the 2x.
Okay, so you multiply it through 2x squared minus 2x minus x squared over x squared. And so you add up with x squared minus 2x over x minus 1 squared.
And then I use the quotient rule again to find the second derivative.
Yeah, okay, so it's just reminding you of the quotient rule. So again, the bottom times the derivative of the top, 2x minus 2, minus the top times the derivative of the bottom, right? Actually, maybe I should ask you, what's the derivative of the bottom? What's the derivative of x minus 1 quantity squared? 2x. What?
2x.
2x? Nope. So you've got x minus 1. So if you differentiate this, this is again a chain rule thing. So you've got your outside function is the squaring function, right? So you again, let's say it like this: your outside function is the squaring function. Your inside function is x minus 1. Right. So you differentiate the outside guy, and you evaluate that at the inside guy. Right. So you get 2 of f of x, right? And then you multiply by the derivative of the inside guy. Well, that's just 1. So you get 2 times 1, right? So I kind of lost my track, but top times the derivative of the bottom over the bottom square.
Is that x minus 1 to the 4th?
Because you had the bottom was x minus 1 squared, and you square it again. Right? You need to have over the bottom square. So you square it again. X minus 1 squared squared. Right. Which is x minus 1 to the 4th.
Can you explain that one more time?
Yeah. So remember the quotient rule says the bottom, take the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom square.
Oh, yeah. Okay.
Right? The bottom here is x minus 1 squared. So x minus 1 squared is quantity squared,
Thank you.
which is the same thing to the 4th.
Okay.
Okay. Any other questions? Okay. Let me give you a more sophisticated problem. Say Px is a degree 2 polynomial. Okay. So it's a quadratic polynomial. And suppose you know and that you know p at 0 is 2, p prime at 0 is 4, and p double prime at 0 is -7. What is the polynomial? What is the polynomial? If you have these 3 facts about it, if you know that its position, velocity, and acceleration at a certain time, do you know the equation for it at all other times? In fact, you can. So think about it for a minute or two, and see if you can say anything. So this is a harder problem. See what you can figure out about P.
Is that asking what the polynomial's limit, please?
Hmm?
The last.
What is the polynomial? What is P?
Oh.
What is P? Right? P is some polynomial, a degree 2 polynomial, right? It looks like ax squared plus bx plus c. Can you tell me exactly what it is, given these 3 bits of information? And the answer is yes. Okay, turn to somebody next spot nearby and say if you have some idea of it doesn't matter. If you have any idea of how to figure out anything about the polynomial.
I thought this was going to be x squared plus x or something. This would be x and this would be because we did the second derivative of x squared. Everything I thought. So this would have to be 7. Like the equation would have to be x plus 7 to give x equals 7. So then I think this I just made it so x no longer equals 7, but 7 times 0 is 0. So I thought maybe I was at 4. Then that would mean that this would be trying to be for x. So I think so 7 times 0 is 0 plus 4 is 4, and that works. And then to make this into something that's squared, 7 over 2x squared, and then plus 4x because we don't have that there. And then that all equals 0, so we add 2 to make it equal to.
Okay, I'm curious if there's anybody who didn't figure out the whole thing, but just figured out part of it. Say, like you can tell me one small thing about the polynomial. Can anyone tell me one small thing, but not more than that, about the polynomial? Megan, how about you?
The C is 2.
C is 2. Yeah, and how did you figure that out?
It has to be 2 if x is going to be 0. There's nothing C equals.
Yeah. So you say, well, I know that p of 0 is 2, right? And I know that p of 0 is c, right? It's a 0 squared plus b 0 plus c, right? So that tells me that c is 2. Right? Okay. Okay, so that's good. Right? You have, if you knew that the position is at the position at time 0 is 2, then you know the constant. You know the constant term, right? You know the constant term in the polynomial. Okay. Well, Megan, how about using the second fact? P prime 0 is 4.
B has to be 4.
B has to be 4, right? Is that right? I think that's right. So P prime 0. Let's see. P prime 0 is 4. P prime is what, 2ax plus b.
So 2ax would be 0.
Yeah. So P at time 0 is that you get b is equal to 4. Right. And so what's the last thing we're going to say? A is going to be what? I'm sorry. A is going to be what?
Minus 7
-7 divided by 2. Mm-hmm. Right, so P double prime is 2A, right? P double prime is 2A, and so P double prime is 2, which is 2A, we know is -7, and so that tells us that A must be -7/2. Yes, go ahead.
Wait, why is it negative?
There was a negative here.
Oh, okay, makes sense to that.
Where did the 2 come from? The 2A?
So remember P was ax squared plus bx plus c, right? Ax squared plus bx plus c.
Yeah.
So P prime is going to be 2ax plus b, right? When you differentiate this thing, you got ax squared plus bx plus c. Differentiate this, you get 2ax. Differentiate this, you get b.
Oh, yeah.
Differentiate this constant, you get 0.
Right, okay, I see.
And then you differentiate again. B is a constant, becomes 0. 0 is constant state 0. 2ax turns into 2a.
Okay.
Right? Okay. So 2a turns out to be the acceleration at time 0. Okay. So yeah. So this is kind of nice. Right? It says that if you know these three things, if you know that your thing is a quadratic, right? If you know that your function is a quadratic, and you know three things about it, right? These three things about it: the position, the speed, and the acceleration at time 0. Then you know it. You know everything about it for all time. Yeah, Sarah.
So what is the second derivative? Is it like because the first derivative is like the slope of the tangent line.
Yeah, it's not so easy to think about, but it's this. So hang on. In this case, right, when you take the second derivative, you're going to get a line, right? I'm sorry, when you take the first derivative, you get a line, 2ax, right? And the slope of that line is the second derivative,
That is okay.
right?
Oh, okay.
Right, so this is a function. This is also a function, right? It's just the slope of the tangent line for that derivative function.
So then wouldn't okay.
Right. So you have one thing over here. This is P. Your second thing is some sort of line, right? P prime is this, and then P double prime is the slope of that line. It's just a constant.
And every value on that line is the slope of like the first one.
That's right. Every value on this line is the slope. Every height on this line is the slope of this guy.
Yeah.
So does that mean that like the derivative, like the third derivative of like anything is going to be 0?
So the third derivative, good. Yeah, the third derivative of any degree 2 polynomial is going to be 0.
Okay.
Yeah, because you see by the time you take the second derivative, you get a constant, right? That's because you have only powers. Your highest power is 2, so after your second derivative, everything is going to be constant, right? After your second derivative, everything is 0. Okay. Yeah, people, I think, maybe there's some way to talk about this graphically, but I think people usually like to talk about it in terms of physics. They'll say, if this is position, this is your instantaneous velocity, this is your instantaneous acceleration.
So does it also have to do with gravity?
Yes, it does. Yes, it does. Yes, we'll get to that. We will get to it. Yeah. So, okay, yeah. So this is pretty cool, right? You can figure out the polynomial by the information about its derivatives at a single point. Right. And this is a setup for something that'll come later called Taylor polynomials. Just to warn you.
Is that this too?
Yes. But I'm not going to get into it. Okay. Okay, so let's go on to section 3.8, which is a really interesting section. Something called the method of implicit differentiation. So here is the sort of example problem. So somebody gives you a circle, x squared plus y squared equals 4. So it's a circle centered at 0, radius 2. Right? And they pick a point on it. They say, okay, here's a point, negative root 3, negative 1. Right? That point is on it because x squared is 3 and y squared is 1. X squared plus y squared is 4. Okay? So you have this point here. And the question is, they ask the question, what's the slope of the tangent line to that curve? Okay. What's the slope of the tangent line to the circle at that point, right? Okay. And this is something you could probably do at this point. You could say, well, look, I can solve for method 1, solve for y as a function of x. Right? You have that x squared plus y squared is equal to 4. So y squared is equal to 4 minus x squared, and y is going to be, plus or minus root 4 minus x squared. Right? Which one is it? Which one is it? Is it plus or minus? Minus, right? In this, for us, we're taking the lower the graph of the minus square root, right? And so it's minus here, and then you just differentiate. Solve for y as a function of x, then differentiate. Right? Y prime is then going to be, well, negative 1/2. I should make you do it. What's the take 20 seconds and write down the derivative of this.
So
Yes.
x squared plus y squared equals 4 is not a function, right?
It's not a function. Yeah.
You make it a function by just taking the minus.
That's right. That's right. Yeah. Yeah, you figure out what function gives y as a function of x. Right, so how do you do it? Somebody tell me. Gwyneth, do you want to tell me? No? You want blank page? Okay.
I'll completely blank for that one.
That's all right. So I'm going to make you do it. Okay. So you've got this thing to the 1/2. You're going to use a chain rule on it. So the outside function is blah to the 1/2. What's the derivative of blah to the 1/2?
You put the 1/2 in front.
And then 1/2 blah to the, yes, exactly, 1/2 blah, right? 1/2 blah to the
Negative.
That's right, 1/2 minus 1. And then you multiply by the derivative of the inside. Right? What's the derivative of the inside?
0 plus x.
0 minus x. Right? Minus 2x, excuse me.
Oh, I see.
Because you got a minus x squared. Right? So you get minus 2x. Okay, good. So that's it. Right. Okay. So, and I guess you can simplify this a little bit, right? The minus 1/2 and the minus 2 cancel off. and you end up with x over the square root of 4 minus x squared.
Why did they cancel off?
Because you have a 1 over negative 2, and you have a negative 2. So you've got negative 2 over 2.
Okay.
Okay, so you have the derivative of this function, right? You have the derivative of the function, and you just, how do you find the slope? You evaluate this at what?
That point.
At the point. So x will be negative root 3, right? So the slope at negative root 3 is going to be negative root 3 over square root of 4 minus root 3 squared. Right? So you get negative root 3. Negative root 3 is the slope. Right. So this is something that you could have done yourself using what your current knowledge. This was within your grasp. It was. Right? There's nothing up here that you haven't seen. Right? There's nothing up here that you haven't seen. Right? You figure out what function describes this lower part here. Right? You figure out what function describes this lower part. You take the derivative and you find the slope there. Right? That's all within your knowledge. Okay. So that's method 1. Sort of figure out explicitly what the function is. Okay. Okay. Method 2 is the method of implicit differentiation. So the idea is this: you assume that y is a function. Assume that y is a function of x. And, as x moves, as x changes, the y changes. So it depends on x. Right? You know it's a function of x. And differentiate the equation. Okay. So x squared plus y squared equals 4. Right? But just remembering that y is dependent on x. Right? Y is actually a function of x. Right? So we're going to write it as a function of x, and then you differentiate. So you differentiate both sides. Differentiate both sides with respect to x. Okay. So what happens? Oh, hold on for a second. So what happens, right? Well, what's the derivative of x squared with respect to x? 2x. What's the derivative of this function of x squared? 2 y to the 1 times times dy dx. Right? And what's the derivative of 4? Well, that's 0, of course.
Then you solve for.
And then you say, well, so I have this relation between x, y, and y prime, right? I have this relation between x, y. This relation up here gives me a relation between x, y, and y prime, right? I take this thing and I just differentiated it with respect to x, and I got this relation. Right? I have this equation, I get this equation. Right? Okay? And the question is, what is y prime at this point? Right? Well, you have an equation involving these 3 things, and you know 2 of them. Right? So you say, well, okay, then at root 3, negative root 3, negative 1, we have that negative 2 root 3 minus 2 prime is 0. Right? Or you can, I mean, maybe to make it simpler, you can solve for y prime here, but sometimes that's not the best way. Well, we can solve for it, fine. So y prime is going to be negative 2x over 2y. In other words, negative x over y. Right? Which is what you're going to get over here, right? Y prime is going to be negative root 3 over negative 2, which we get, over positive 2, so you get negative root 3. Okay, so y prime is negative root 3, just as it was before. Okay, Kelly, yeah. Okay, but notice that we didn't solve for y, the function, explicitly, right? And we didn't need to, right? We didn't need to. What we did, rather, was differentiate our original equation to get an equation involving relating the derivative to the x and y coordinates, right? And then you have the x and y coordinates and you solve for the derivative. Okay, so this is the method of implicit differentiation. Yes, Mark?
Wait, why is it called implicit?
Because you don't solve for x, you don't solve for y explicitly. You don't solve for the function explicitly. You just say, I know it's a function, right? It's implicitly a function given our graph here. Okay. So does that make sense to people? Anyone have any questions? Just out of curiosity, and it doesn't, there's no right answer to this question. Which way do you like better? Who likes method 1 better? Okay. Who likes method 2 better? Okay. I'd say each has its advantages. So there's no reason to say that one is better than the other. Okay. So okay. It's not too much time, so let me instead of having you do these, let me do them myself. So here's one. Xy squared plus yx squared equals 6. And the point is 1, 2, and you want the equation of the tangent line. You want the equation of the tangent line. Okay. So this is one where maybe it would be a little bit tricky. It's not impossible, but maybe it'd be a little bit tricky to solve for y. Okay. You could do it. But it'd be a little bit tricky. Okay. So instead of solving explicitly for y, we're going to use the method of implicit differentiation and say, well, okay, I know that this is some sort of graph, and so y is really a function of x, and so I'm going to write it as a function of x, and I'm going to differentiate. Okay. So what do I get? I'm going to get the first times the derivative of the second plus the second plus the derivative of the first times the second. Maybe I should let you do it. Somebody tell me? I'm going to say it again. So the first times the derivative of the second. What's the derivative of the second? 2y dy dx. 2y dy dx plus the derivative of the first, which is 1, times the second. So we've just differentiated this first term. And now we need to differentiate the second term. Right? So the first times the derivative of the second. First times the derivative of the second times the derivative of the first times the second. And we need to differentiate the right side as well. Yeah, Clay.
How'd you get the yx squared?
That is just the part of the product rule. First times the derivative of the second Second times the derivative of the first. Right? Second times the derivative of the first, which is 1. I should say that people usually don't write it out. They'll just leave it without, they'll just write it like this. X 2y y prime plus y squared plus y times 2x plus y prime times x squared. So, maybe that's cleaner. They leave the function indication out to make it simpler.
And you use the chain rule, right?
Yeah, we use the chain. Well, we use the chain rule here. Okay. Anybody have questions about? Anybody have questions about how we do this? No, there's absolutely no shame in asking. Gwyneth, you're smiling.
I'm smiling because this small part is making sense so far.
Oh, great. Okay, good. So good. Okay, so then the question is what is our question is what is y prime, right? We want to find the slope there. So it's a hassle, but let's plug in everything, right? X is 1, y is 2. So we get 1 times 4 y prime. We get 4y prime from this term, right? We get y squared. 2 squared is 4 plus 2xy. So that's 4 again, right? 2 times 1 times 2 is 4 plus x squared. That's 1 times y prime equals 0. Okay. So at 1 comma 2, we get this, right? And so we get that 5y prime equals negative 8. Okay. And then, so y prime is negative 8/5, and that, with the point, gives us the equation of the tangent line, right? Because we have the point, so our tangent line is going to be y minus the point, y coordinate equals negative 8/5 x minus the x coordinate. Okay.
Can you do that last step again?
Yeah, so the slope, right? You have the slope of the line already, and you have the point. You have the point, right? So you use the point slope formula, right? You have the point and the slope. So you use the point slope form. Y minus the y coordinate is equal to the slope times x minus the x coordinate. Okay, so this is the method of implicit differentiation. You see how you do it. You start with the equation, and then just differentiate it, understanding that y is a function, y is implicitly a function of x.